Hi everyone, welcome back. I'm having fun with doing this and how to improve it and make it better. Keep thinking about if you were sitting here with me, I'd just be having a conversation with you. And sometimes I like to muck around in ways to get people's brain to think, because I found that there's a lot of people out there who don't do well at maths, but they really can think maths and think it really well. I've proved it with adults as well. Have a look at this, what I've got here. In the last video I had doing videos like x plus 1, x plus 2. If you haven't seen that, you can go back and watch that video. So here I've got a line which is just y equals 2x. Now, to be fussy, in the last video I put plus 0. Then I talked about, okay, now what I can do here, if I click on this table, it lets me get these points on the graph. So let's have a look at this 2x. So I click over here and I've got this point called 1, 2. There's another point over here called 2, 4 up the top. And if you follow my massive cursor down the bottom, I've got 0, 0. I've got all those points on there. So if you have a look at this graph, it's going through those points. What happens if I get rid of all of that? And instead of having 2x, oh, by the way, I haven't mentioned that goes through, of course, at 0, 0 here. Goes through at the intersection of the x and the y axes. So what happens if instead of having a 2x plus 0, before I even teach you about it, what happens if I made a 3? Oh, look at that, it goes steeper. Be interesting though. No, I don't want to do that. If I put up lots of graphs on there, it can be confusing. So watch what happens when I get rid of that 4. It goes back to this one. What I like about the one called y equals x, it just goes up here straight through the middle of all these corners. It's actually, we'll talk about, for those who understand it, it's at an angle of 45 degrees. And if you follow my cursor across here, it goes across one, and it goes up one. And it goes across another one, goes up one. So you can get to each point on the screen. So to get to that point there, which I've just clicked, I won't stay there. I've got to get the table back. Sorry about that. I'm still getting used to this. So to get to that point there, from this point, so to get through to 1, 1 from 0, 0, we go across one and up one. And by the way, if you look at the name of the graph, it's called y equals x. So whenever we put in for an x value, like down here, put in 0 for x, we get 0 for y. When we put in 1 for x, we get 1 for y. So guess what we get next? Put in 2 for x, we get 2 for y. And if I click on the next one, oh, it won't let me because I haven't gone far enough on the table. So I'd have to extend this table, and then I can get the next point up here, which is, so if I want to go from 2, 2 to 3, 3, goes across one and up one. Now I've got to get rid of all that, or otherwise I'll confuse things. So now if I put in a 2x, and if I get the points up, maybe this will help. Most people won't need this long, but there are people that do. So if we start at 0, 0, we go across here to 1, 2. So how do I go from 0, 0 to 1, 2? And it goes across 1 and up 2. Now, if no one ever made up rules about this, I think I did this when I was a kid, mucking around with drawing graphs on grid paper. So if you went from 0, 0 to 1, 2, people talk about you can go across 1 and up 2. So you could look at that and go, ooh, that's twice as steep as the other line. I am going to put the other line back in. So if I put in y equals x plus 0, which I don't need to put plus 0. So this line with the dots on it is twice as steep. It's a bit weird to say twice as steep as the other line. So this line goes through, if I get the points up on it, and he's getting the points up on it. So this point here goes through at 1, 1, and this goes through at 1, 2. And if I add another graph in, which would be y equals 3x plus, and I don't have to write plus 0, but I'm still writing it. And if I said I want the coordinates on it, so this one goes through at 1, 1. This one is y equals 2x, goes through at 1, 2. And this one's y equals 3x. And people think, oh, it goes through 1, 2, 3. But I'm going to get rid of all that for a moment. Let's get rid of all that. Because sometimes people think things that are not true and it mucks their brains up. Let's go back to this graph here. Instead of having y equals x plus 0, I got y equals 2x plus 0. I've got 2x plus 1. So now it goes through, if I get the coordinates up again, it goes through at 0, 1, which is called the y-intercept, and from the 0, 1 it goes across 1 and up 2. And if I get to the next point, it goes across 1 and up 2. By the way, you could go back down to here. See, people will talk about goes down. I don't like the down word, because I find with a lot of students when I talk down they get confused. So if I go back down here to this point, which is -1, -1, so I'm heading up all the time. Goes across 1 and up 2. Now you'll have maths teachers in class who talk all sorts of way, and there'll be lots of teachers talk about the D word, down, and all that sort of stuff. So I need to get rid of that. And what happens if I go y equals 2x plus 2? You can still see, if you follow my cursor, it goes across 1 and goes up 2. Now, it doesn't have to be on the corners, but the corners make it much easier. So if I go back down, I want to get rid of that for a moment. I'm going to move the screen down a bit. So now we've got 2x plus 1. What if I made it y equals 3x plus 1? So it's still going to go through 1, so they both go through 1. What I like about it is they both have a y-intercept of that point there at 0, 1. But the 2x plus 1 is not as steep as the 3x plus 1. Now I'm going to muck everyone up on purpose. I like this though. We're going to put in something like y equals, and I'm going to go 1/4. And I've got to get out of there, 1/4 x plus 1. And I wonder how many people looking will suddenly go, oh, now I've got it. So let's get the points up on this one. So I've got these points on here. Now the points aren't enough, so I've got to go down here and put in 4. So if you look across now, we're going to go from 0, 1. Now, I could use these other dots like this one here, but if you look at it, it's got decimals. I talk about it as yucky. This one's got 1.5. It's a bit yucky. Not too bad, but you have to think about fractions, and a lot of people are terrible at fractions. Let's go to that one there, 4, 2. So I want to get rid of these others, so we don't need them. So how do I go from 0, 1 to 4, 2? I go across, if you follow me, I go 1 complete square, 2 squares horizontally across, 3 squares across, 4 squares across, and 1 square up. Now, a lot of people go to write that as 4 over 1, which doesn't make sense because 4's on the bottom and 1 goes up on the top. So it's not 4 over 1, because 4 over 1 would be steep. This is 1 over 4. Now, I'm going to go a little bit further. What if I made it a weird number, like, say, oh, what am I going to go? 2 over 3. So we need some points again, so I get the points, click on that one. There's my points. I want this point over here, so I need another point, call that 3. So now we're going to start at 1, which is 0, 1, and go all the way across here to this one. And boy, that mucks up people's brains. I have thought about trying to put in horizontal and vertical lines, but it won't let me very easily do that. I will do it once on here before I finish the video, but it's getting too long. If I put a line through here at 1, this will be interesting for your understanding. It's just called y equals 1. So there's that nice blue line across there. Now I put in another one, which I want to go upwards, and see if this point up here is above the 3 on the x-axis. So here's another thing you haven't learnt as yet, but you might have already learnt in class. So this horizontal line that I'm showing is x equals 3, and that's this one over here that I've highlighted on the left. If I highlighted y equals 1, that's this one that goes acrossways horizontally. Interesting. So if I want to go now from 0, 1, it won't stay there. Now it will. From 0, 1 to 3, 2. So let's go across. We're going to count crossways, starting 0, 1, 1 box across, 2 boxes across, 3 boxes or 3 grids across, go up 1 and go up 2. So we've come across 3, we've gone up 2. And people get mucked up and call it 3 over 2. It's not 3 over 2. 3 is on the bottom, 2 is on the top. So if you look back to my graph over here, which I'm going to highlight, back over here, you see it highlighted now. The 2 over 3 means it goes across 3 and up 2, and that's called the gradient. And then the 1 is the y-intercept. So if I got rid of this table and I made it just, get rid of that table. if I get rid of this other stuff too, if I just made it y equals 2x plus 0, what happens? There it is. If I start at 0, 0, it goes across 3 and up 2 to that point there. There it is, somewhere there, nearly on the point. Nearly. There it is. And by the way, if I wanted to, I can go across another 3 and up another 2, and I get to this point up here, which is, I can't quite get it, 6, 4. There it is. So that's called the gradient. So if I turn this gradient into 1 on 3, starting here at the y-intercept, I go across 3 and up 1. And again, I can go across 3 and up 1. What if I made it a half? Let's go to there. If I made it a half, and I'm going to make it plus 2, and I can get rid of all these others. Here we go. So maybe it sinks in. Sorry guys, the video's too long. But I think there's a lot of people out there could do with watching it and taking their time. Or watch a half at one night and half another night. Let's have a look at that. As a y-intercept of 2, there it is. And it's got a gradient of a half. Let's look what happens. So if we start here at 0, 2, we go across 2 and we go up 1. We get to that dot there. And if we go across another 2 and go up 1, we get to that dot there. If we go right down to the start, right back down here, I need to get rid of that a bit. Right, there we go. Move the screen. If I go to that point there, minus 2, 1, I can go across 2. Whoops, I've got to let go of the dot. Across 2 and up 1, I get to there. So that's a gradient of a half. So look back to this. If it says y equals the number that's written in front of the x, which is called the coefficient of the x. Hear that word? Coefficient. So I wonder if I can type that there. What would happen? Coefficient. Oh yeah, that's interesting. That's the coefficient of the x. So that's the number. Oh, won't let me. The double F's look funny. So the coefficient of the x is a half. So I'll get rid of that again because it doesn't understand it. So 2 is the y-intercept. So I'll go one more. Let's do it. Let's go really weird one. Let's go 4 on 3 and plus 2. So if I move it, let's go plus 1. It's going off the screen too much. So here we go. So the 4 on 3, does that mean I go across 3 or across 4? The bottom is the 3, so I start here at the y-intercept. I go across 3 and I go up 4. So slowly, 3 boxes across, 3 corners across, 1, 2, 3, 4 corners up, and I get to there. So I have a gradient of 4 on 3, not 3 on 4, and a y-intercept of 1. And if I turn this into minus 1, just like that, so I move it down so you can see it. If I start there, I can go across 3, so ready, from minus 1, across 3, 1, 2, 3, and up 4 corners, 1, 2, 3, 4 corners, and I'm up to there. The interesting part is I can go anywhere on the graph, like right up here somewhere, and that point is 6, 7, you can't tell, but unless it tells you. I'm going to go across 3 from there, 1 across corner, 2 corners, 3 corners, there's 3 corners, go up 4, 1, 2, 3, 4. So there's my 4/3 over here. I just highlight the 4/3. 4/3 called the gradient, and minus 1's called the y-intercept. I hope it helps. Thanks for watching. Bye for now.